Okay, so we're talking about the derivatives of inverse trig functions. This little paragraph here, I would maybe pause it and read it, but it's basically explaining the subtle differences in the patterns of these 6 derivatives. If you notice, again, the sine and the cosine, the tangent and the cotangent, the secant and the cosecant, the derivatives are very similar. The only difference, actually, is that all the cofunctions are negative. They all have a 1 on top. They also all have an x squared and a 1 on the bottom. And then from there, the differences are very subtle. So this is the square root of 1 minus, this is just 1 plus, this is the absolute value of x, and then x squared minus 1. Very similar. So we're going to go ahead and do these derivatives. Let's take a look at example number 1 first. And you'll notice that this is definitely a function inside a function. So right away we are going to have to do chain rule. So I'm going to go ahead, first thing I'm going to do is do u. It's a weird u. Equals x squared. And therefore du equals 2x. So let's rewrite this. Y equals the cosine of -1 of u. And so we should be able to just quickly see what is the derivative of cosine, or I'm sorry, this is the inverse cosine or arc cosine. And it's -1 over the square root of 1 minus x squared. So let's go ahead and do that. Only difference is it's not going to be x here. It's going to be u. And because this is chain rule, we are going to have to remember to multiply by the derivative of, in this situation it would be dx, which they put over here, but we know that it's not dx, it's u. So we're going to have to multiply this by du. So let's clean it up. We got -1 times du, which we know is 2x, over the square root of 1 minus, and my u is actually x squared, so this is going to be x squared. So if we clean this up a little bit, we get -2x on top, and on the bottom we get the square root of 1 minus x to the 4th. And that's it. That's all there really is to that problem. So really these are just more derivatives you have to memorize. I know, there's a lot of just memorizing derivatives here. A lot of formulas to memorize. I would recommend you make some flashcards and just start making them, because there's just a lot of little things you got to memorize. On example 2, I'd like for you to try it on your own. Again, very similar. It's going to be u substitution, so give it a shot. And then unpause the video when you're ready to check your work. Alright, so my u is obviously going to be this 5x cubed, therefore my du is 15x squared. Now I'm just taking the derivative of cosecant -1 to the u, and that is right up here. It's just this formula. Instead of x's though, it's u. So plug it all in with the du out here. And since I'm multiplying by the du, I can just technically just put it on top, which is what I did here. -15x squared, because that's my du, over the absolute value of my u. Square root my u squared minus 1. Since this is being squared, I went ahead and simplified it. And there we go. So, you could probably do some simplifying here, but that's not really what we need to do here. I just want us to get to the derivative, and that's good enough. Let's go on to the next one. Okay, now we're looking at what looks like a chain rule, because I have a 2x inside the arc sign here, and an x squared. So, let's go ahead and do this. But let's first start off by setting our u up. So, my u, my stylus is acting kind of weird. My u is 2x, and therefore my du is just 2. So if I was to rewrite this, it'd be the arc sine of u over x squared. And now we could take the derivative, but we got to remember this is actually a product rule a quotient rule situation, because we're dividing. So we're going to do the derivative of the first, or the derivative of the top, which is just this. So the derivative of the top would be 1. Let's write this as f prime of x. 1 over the square root of 1 minus u squared, and then I can just times by du on top. So that's just the derivative of the top, though, remember? That's the derivative of the top times the bottom, which is x squared, minus the top times the derivative of the bottom, which is 2x, all over the bottom squared, and x squared squared would be x to the 4th. Okay, it's a little nasty. Actually, it's really nasty, but that's okay. We could plug everything in that we need to plug in, and we're pretty much done. So let's just go ahead and do that. I have a 1. I don't really need to write that, but I could plug in my du, which is 2. And I could plug in my x squared, because I'm just multiplying. So right here, I could just go right on top. So that's just like a 2x squared over the square root of 1 minus, my u, remember, is just 2x. So this is 2x squared minus the arc sine of my u is just 2x. And then this times another 2x. And that whole thing is over x to the 4th. Now, at this point, you might be able to clean this up a little bit, but you know what? I'm not even going to mess with it. I'm going to just leave it like this. This is a big, nasty derivative, and I'm just going to leave it like that. No point in really simplifying this, because, I mean, you got an arc sine over here, you got a square root on the bottom over here, a whole bunch of stuff here. It might simplify a little bit, but I'm fine with how it is. Let's go on to the next problem. Alright, so this looks like a double chain rule, because you got a function inside a square root function inside a cosecant. I think you guys can do this. Just use your u's and your v's properly, and I think you'll be just fine. So go ahead, pause the video, give it a try, and then unpause it when you're ready to check your work. Okay, this guy is a doozy. So let's first start off with our u substitution. We know that the innermost part, 3x squared plus 1, is going to be our u. And we know that when we plug in a u, we still have a square root of u. So you're going to need to substitute in a v for square root of u. You do all your derivatives, and then you have the cosecant, the inverse, or the arc cosecant of negative 1 of v. Now, when you take the derivative of this, you get negative 1 over the absolute value of v, square root, v squared minus 1 times dv. This dv can just be multiplied up on top, which is why I put this guy on top, because dv is just really du over 2 square root u, divided by v is just square root u, square root v squared, which is square root of u, squared minus 1. And I put this little over 1 here because I want you to think of this as a fraction over a fraction, which means you can take this and flip and multiply. So let's plug everything in. Let's plug in the top here, because if I flip and multiply, I would really just have a 1 times negative du. Well, du is just 6x, and this is negative, so this is just negative 6x on top. On bottom, I would have a 2 square root u. Well, that's my u. That's supposed to be a little plus there. Right, 2 square root u. Then I have the absolute value of the square root of u, 3x squared plus 1. Then I have the square root of u squared. Well, u squared, if you think about it, that's just u, isn't it? Because it's the square root of u squared, so that's just u. And u is just 3x squared plus 1, but I'm still subtracting 1. So, pay attention to what I do here. I got the 6 and the 2. That reduces to just a negative 3. Then, a couple of things here. Right, so I'll cross this out and say that's where I got the negative 3. Now, this takes a little bit of thinking here. I have the absolute value of 3x squared plus 1, but it's underneath the square root anyway. I'm already only going to get positive numbers here, and I can only get positive numbers here, because I'm taking the positive square roots. So, since I'm only taking the positive square roots, I'm really asking for the absolute value of either of these, and so I really have a square root times a square root. Well, square root times the square root equals just what's on the inside, but I'm going to leave it inside the absolute value. So that's where this 3x squared plus 1 comes from. Now, where did this x come from? Well, let's take a look at what's left. I have the square root of 3x squared plus 1 minus 1. So really I just have the square root of 3x squared. Well, if you take the square root of an x squared, it's going to always be positive. It's just the x, but it's the absolute value of the x. So that ended up right here. All that was left was the square root of 3. I went ahead and rationalized the denominator because I thought I would clean it up a little bit better. So I multiplied by square root 3 over square root 3. And when you do that, well, you're going to end up with x times rad 3. That's where this comes from. But this 3 here is going to cancel out with the square root of 3 times the square root of 3 here. So these guys all cancel out. And so you have just negative x square root 3, and then all you're left with is the absolute value of, I went ahead and distributed that x in, 3x cubed plus x. I know, this is probably the nastiest one I've seen so far this year. A lot of work, a lot of thinking. Takes some space to kind of keep organized and think about all the little tricks to do here. But this is a good problem. A lot of fun here, a lot of interesting stuff to think about. All right. Hopefully that's helpful. We'll see you guys on the next video. All right.